Welcome to Intro to Pandas, the first course in the Master Data Analysis with Python series. I'm your instructor, Teddy Petru, and here's a course overview. So first, a little bit about me. I'm the author of multiple books, including Pandas Cookbook, Master Data Analysis with Python, and Master Machine Learning with Python. I'm also the founder of Dunder Data, a professional training company specializing in the Python data science ecosystem. I've taught thousands of students both in person and online, including employees from Microsoft, NASA, and the US government. I'm also the developer of multiple open source Python libraries. So what is Pandas? It's a powerful and popular Python library for data analysis. So if you're interested in doing data analysis and want to do so using the Python programming language, then Pandas is your tool of choice. So here are a few things that Pandas can do. It can query the data, which means choosing a specific subset. It can transform data from one form into another. It can aggregate or summarize data, and it can produce data visualizations. For our current course, Intro to Pandas, we have the following course objectives. You'll be provided an introduction to the Jupyter Notebook. This is a powerful tool to write code and text within the same document, and where all of our code will be written. You'll get an overview of all the kinds of data analysis capable with Pandas. You'll get introduced to the data frame and series, the two primary containers of data in Pandas. You'll learn about the different data types available within the data frame and series. You'll learn how to set a meaningful index for the data frame and series. And finally, you'll learn a simple process for doing data analysis within a Jupyter Notebook. As you can see, Intro to Pandas is the first part to the very comprehensive Master Data Analysis with Python series. And by the end of this sequence of courses, you should have confidence producing trusted results in a professional setting using Pandas. Here's what you'll get: 5 Jupyter Notebooks, exercises with detailed solutions, and a PDF of all the course content. If you're looking for a comprehensive path to mastering Pandas for data analysis, then come join me and take Intro to Pandas. Welcome to the Python and Pandas installation with the Miniconda distribution video. So if you already have Python and Pandas installed along with Jupyter Notebooks, you can go ahead and skip this video. I wanted to provide this video for those that want a straightforward path to installing all the correct libraries for this course. Okay, so if you look over here on the right hand side, there'll be a resources section for this video, and if you click down, you'll see that there's a Python installation PDF. This PDF contains all of the specific instructions for setting up your system for this course. I've already downloaded it and opened it up over here. So here's this PDF, and it goes into considerable detail over many things, such as the Conda packaging package manager, the difference between a package manager and an environment manager, what a distribution is, and then all of the steps to install what's called the Miniconda distribution. So the Miniconda distribution is what will contain Python along with the Conda tool, which allows you to install packages. So that's what I use, is this Miniconda distribution with the Conda package and environment manager. Okay, so this video is just going to show you a brief overview of what is contained in this PDF document. It'll be up to you to follow this document to get all the software installed correctly. If you already have Python but don't have Pandas, then you should be able to install Pandas very quickly by just doing pip install Pandas and Jupyter like this. Or if you already have Conda, then you can just install it with Conda install Pandas space Jupyter. So this is installing two separate packages, both Pandas and Jupyter. So those are both necessary for the course. Now, so continuing with the brief overview of how you can get started with the specific instructions, you'll navigate to this Miniconda site. So Miniconda is a distribution. It's created by the Anaconda company. So the term mini should help you understand that this is not the full Anaconda distribution, but a much smaller distribution. The full Anaconda distribution installs Python along with many other third-party libraries that are common to scientific computing. I like the Miniconda distribution because it only installs Python and the Conda tool along with just a few other third-party libraries. So you can save a considerable amount of space when using it. So if you go down here, you simply select your the download for your operating system, and then really you can just follow the defaults to install it. And you can see now that it comes with Python 3.9.5. So once you've installed this software, then you're almost ready to go. You can just hop over here to either your terminal or your command prompt. So if you're on a Windows machine, you will open up actually something different, but for Mac and Linux machines, you will open up a terminal and open up one with a little bit larger text. So if you are on a Windows machine, you will open up a program called Anaconda Prompt, and it'll look similar to this terminal right here. This is simply your command prompt that has the base environment already active. So once you've installed Miniconda and you're either have a terminal open or your Anaconda prompt, you'll simply just install the software with pip install, you could say pandas and Jupyter. I provide several other packages that you can install for the most common ones used in scientific computing and data science in the PDF, but really just for this course you can install pandas and Jupyter just like that, and then you should be good to go. And anytime to do any part of the course, we'll open up our terminal and run Jupyter Notebooks, and that'll be covered in the next video. But make sure to read this PDF. It covers a lot of good things and goes into a lot more detail about environments and distributions and package managers. All right, so that's how to get set up with Python and Pandas. Welcome to downloading the course material. If you're watching this video, then you should be on this page. There will be a video here in place of this text. So what I want you to do is look over here on the right-hand side of the screen under the downloading the course material section. You'll see a resources button. Go ahead and click that, and then click the link below it to download the course material. Place it somewhere either on your desktop or your downloads folder. We will be moving it from there. So once it's finished downloading, go ahead and unzip the contents. And inside here is where all of the course material is. Now, it's on my desktop. It might be on your downloads folder, but regardless, those are not good places to keep the course material. I suggest placing it somewhere else in your file system. One thing that you can do if you are taking several courses from me is to create a Dunder Data courses directory. I founded a company called Dunder Data, and it's going to help you keep all those courses organized. So I'm just going to go ahead and drag and drop the course material over here into that folder. Here are the contents which we will cover in an upcoming video. Let's continue by exploring the course contents. So I've expanded this out to see the full name of the course, Master Data Analysis with Python, Intro to Pandas. So as you recall, Master Data Analysis with Python is this extremely comprehensive series of courses, and Intro to Pandas is the very first one. The digits over here just represent the last time the course was updated. So let's go ahead and take a look at the contents. We have a couple of folders and then a file. This file simply adds some style to the visualizations in the first chapter. We'll go much more into what this file is in the data visualizations part of the series. All right, so let's go into this book directory, and we can see that there are two files here. They're both PDFs. One is of the solutions, one is of the full content of the course. Let's go ahead and open up just the full content of the course. So you'll see here, and as we scroll down here, the table of contents. Now this PDF is actually an unnecessary part of the course. This places all of the contents into a single document. We will not be using the PDF. This is just produced for your convenience so that you can have a static document of all of the contents and go through it at your own time. We will be going through the course within Jupyter Notebooks, which are dynamic. We can run code, we can add cells, we can add notes, and do the exercises. So we'll be doing all of our work within the notebooks and not using this PDF. So just use this for your convenience when you want to read on your own time. And here's the actual book part. And you'll also notice that there is not just intro to pandas here, but selecting subsets of data. So that is the very next part as well. The solutions PDF just has the solutions in the PDF. We won't be using that. We'll be covering all the solutions in the notebook. Okay, so the main part of the material is this Jupyter Notebooks folder, and then you can see here the two parts of the course, or the two parts of Master Data Analysis with Python. We have Intro to Pandas, so we will begin here. All the files in here are Jupyter Notebooks, and we will open them up in just a second. You can see the next part, selecting subsets of data, also has many Jupyter Notebooks. So you can think of every notebook you see here, and that's what these IPNYNB files are, as chapters. So there are many chapters in each part of the book. And then finally we have this data folder, and this just has all of the data for the course. All right, so that covers all of the course contents for you for this course. In this video, we'll cover how to open up the material with a Jupyter Notebook. So the Jupyter Notebook system is what we will use to go through all of the material in the course. That's how you'll read the text, enter in code, execute code, and make notes for yourself. So to get started here, what you'll need to do is open up a terminal if you're on a Mac or a Linux machine, or Anaconda Prompt if you're on Windows. You should see that you have the base environment active if you install the Minikana distribution. And what we'll do here is simply type in Jupyter space notebook, and this is the command that you'll use to launch this Jupyter Notebook system. So let's go ahead and do that now. This will open up a new tab in your browser, and the first thing that you'll see is what I call the file system view. This is not a Jupyter Notebook yet. I will have a separate video coming up on just more of what is possible with a Jupyter Notebook and all the tips and tricks with them. This is just to show you how to open one up and how to open up the material. So whatever directory that you launched Jupyter Notebook from, over here in your terminal is what will show up over here. So by default on your terminal, you will be placed in your home directory. So wherever that home directory is for your particular system, Linux, Mac, Windows, you will see the contents of that home directory. So this is where you need to know where you placed the folder for this course. I suggested to make a Dunder Data Courses folder. Now this might not be in your home directory, it might be somewhere else. But what you'll have to do is navigate to wherever that folder is. So you have to remember where it is. This is just like your file system view and gives you that same kind of navigation feel. So these are just all the folders in my home directory. I will click on Dunder Data Courses. That's just a folder. You can see the little icon over here. And here is where I have placed the material for the course and all of its contents. So I'm going to click again. And now I'm inside the directory for the course. And you can see we've already covered all of these items. And what I need you to do is navigate one more time into the Jupyter Notebooks directory. So here are the different parts of the Master Data Analysis with Python series. This is part 1, Intro to Pandas, and that's where we'll begin. You also have the second part, selecting subsets of data, but we'll begin with Intro to Pandas. So let's click on that. And finally, we see the Jupyter Notebooks down here. These are the ones that we're going to go through one at a time. So just click on one of the notebooks. These are the ones that end in IPYNB. They'll have that little notebook icon in front of them. So this is the first chapter of the book, What is Pandas? And this will display all of the text and code for the book. So yes, this is the content, and that's how you access it. And you just kind of read it like a book. And we'll cover in the next video about the difference between markdown cells, which have text, and then code cells, which allow you to run code. So just go down here, and this is just showing you some examples of pandas. This will all be covered in great detail in the following videos. I just want to show you how to open up a Jupyter Notebook and how to access the material. Let me flip back over here. Now, how do you shut this down? Well, you just press Control C once. It'll ask you, do you want to shut down this notebook server? You just say yes, and then you're back over here in your home directory. Now, there's one other way I want to show how to access the material. You don't have to launch Jupyter Notebook directly from your home directory. If you know its location, you can say, I want to go into Dunder Data Courses. I'm going to CD there first, so you have to know some commands, some file system commands like this, and then I will go one more level deep into the actual course folder like this, and then I will launch Jupyter Notebook like that. So from the course directory itself, we'll open up, we'll get that file system view. So now I'm dropped directly into the location that I want, and then I can go and open up the notebooks like that again. All right, so that's how you can open up the material within a Jupyter Notebook. In this video, I'm going to provide an introduction to Jupyter Notebooks. So the Jupyter Notebook is the tool that we will use to go through all of our material. So it's vital that you have a thorough understanding of how the notebook works, and I'm also going to provide many tips and tricks as well so that you can use it very effectively and efficiently. If you take a look over here on the right-hand side, you'll see a resources folder and then a link to a PDF, which I have over here. This is a little booklet that provides a lot of information on the Jupyter Notebook. It is broken down into 4 chapters. I highly advise that you read this before continuing so that you have a really thorough understanding of the notebook. Now, in this video, I'm going to go through some of this material and show you what it looks like in a notebook itself. So I've just created this notebook and going to use it to explain what Jupyter Notebooks are, and then many tips and tricks that you can use as you go through the material. So number one, a Jupyter Notebook is composed of cells. Everything that you see in the notebook is a cell, just like everything in your body is a cell. Everything in a notebook is a cell. There are 2 main types of cells. There are markdown cells and there are code cells. And you can identify the cell by the highlighting. There's always one cell that is active or that is selected, and that is the one that is highlighted. And if you just click on down over here on the left side of the page, you don't necessarily know when the cell begins or ends, but if you just click somewhere, it will highlight some region, and that region is considered a cell. So there are 2 types, like I said, markdown and code cells. The markdown cells will have nothing over here on the left-hand side. You'll also see the word markdown over here in this drop-down menu. So you'll know that it is a markdown cell like that. It'll contain text over here, which you cannot change immediately. Code cells, on the other hand, always have this word in next to it and then some parentheses. Inside the parentheses, you'll see there'll be a number. That is the order of when the cell was executed. Notice that the drop-down menu over here changed to code. So markdown and code cells. So obviously the code cells is where you write your Python code. They understand Python code. The markdown cells understand a plain text language called Markdown, which we will discuss in a little bit. Essentially, it renders as a just text. You can put images and links in Markdown. You can think of it as an easy way to write HTML so that it looks nice and presentable. Okay, so moving on, there are two different modes to cells. So both Markdown and code cells are always in one of two modes. They are either in edit mode or command mode. So edit mode is when the cell is highlighted in green, there's a blinking cursor, and then you can actually edit it directly by typing in just plain text. So let me show you that. It's easiest to show this in a code cell. We will move on to markdown cells later on. So now I'm going to click inside of this text part of the code cell. So notice we're in a code cell. There's a couple changes that happen. So number one, let me click it over here on the left. When it's highlighted in blue, it is in command mode. But the second I put my cursor in here, it is now in edit mode. And you can see there's now a blinking cursor that should inform you that whenever you press the keys, they will output exactly what you are pressing. The cell is also highlighted in green. You will see this little pencil over here letting you know that you are in edit mode, and you can see the little tooltip. It does say edit mode. All right, so that is how you can differentiate between command and edit mode. And if I click over here, let's say on the side, I can turn it into command mode. Now the little pencil is gone. It is highlighted in blue, and there is no blinking cursor. There's a way to get to edit mode in a markdown cell. I will show that in a little bit. All right. So primarily, you're going to be working within code cells. You're not going to be writing a whole lot of markdown. You can add notes to your notebook with markdown, but primarily during the course, you will be inside of a code cell in edit mode typing in your code. So you need to know how to execute cells. So let's go ahead and do a simple mathematical operation in Python. Maybe we'll add 5 plus 7 like this. Now, if you press enter, you'll notice that enter does not execute the cell. It simply adds in a new line. It treats it just as if you're writing an email or just writing some more text. To execute the cell, you need to press Shift and enter. And when you execute, you'll see that I must have already executed something in this notebook, but it should say the number that is associated with the order of execution. So if it's the first cell that's executed, it'll be 1. If there's any output, you'll see this word out next to it. And here the result is 12. So that's how you execute it. And let me do that again and execute it one more time. The execution number went up. Now when you execute, if you do have a cell below, it will highlight it and place you in command mode. So that's a little interesting that it drops you into command mode after you execute a cell. To go back in, you'll have to just press in there and make it into edit mode. Now there's another way to execute a cell to keep you in that cell. If you press Control Enter or Command Enter on a Mac, you will execute the cell and stay in that cell in command mode. So I pressed, instead of Shift Enter, I pressed Command Enter. So that's an additional way to execute the cell. All right, so there's a little bit more to execution. Let's just say we do a variable assignment, such as we assign the value of 10 to the variable A, and we execute this. So I'm going to press Shift Enter here. And you notice there is no output. So This line, when you have an assignment statement, produces no output, so there's nothing for this out. There's no output of the cell. So that's important to know. Also, if, let's just say, we can have multiple lines of code in here. We could say 7 plus 5, and we execute that. So notice that there's still no output. It doesn't mean that this did not run. What happened was this first line executed, but the way the cell works is that only the last line will show its output. So we did execute this, but we did not output it. It was not the last line of the cell, I should say, so it will not be seen in the screen. Now let's delete this line, and then let's do another line of code here. So in this instance, we have 2 lines of code. They are both executed, but only the last one is revealed. And that's just how the rules of the notebook work, is that only the last line will be seen. So it doesn't matter how many lines of code you have, only the last line will have its output on the screen. Okay, so let's move on. So now you know how to execute cells. This is what I think is very important, helping you maneuver through the notebook, is that there are several keyboard shortcuts that I believe you must know in order to just make your life a lot easier within a Jupyter Notebook. The first one is how to change between edit and command mode. Okay, so let's just say you're in a cell and you're just writing out some code and you want to change to command mode. I should change this around. This is escape changes to, command mode. Enter changes to edit mode. So that was some markdown I just revealed. I will cover that in a little bit. So to change to command mode, you tap escape. You don't have to hold and press escape. And notice when I press escape here that the cell will be highlighted in blue and the little pencil will go away and the blinking cursor will go away. Now to go into edit mode, you press enter to get you back into edit mode. So what I usually tell my students is just to keep practicing this. Escape to change to command mode, edit to get back, or enter to get back into edit mode. You'll be doing this quite a lot. Escape, enter, enter, escape, enter. Okay, now when you're in command mode, so I've pressed escape. Now the keyboard changes such that the keys do not just type what they are onto the screen, right? So you're literally going to command this notebook to do something. The command is not to be a literal character on the screen. They all, not all, but they map to other things, other actions. So let's go down the list. These are just a few of them. There are more, but these are the main ones that I use. They're just single letters. So once you're in command mode, which I am right now, so I am highlighted in blue this cell, I can press, say, A. That will insert a new cell above. So A is for above, and I can keep pressing it, A. That'll keep adding cells. If I want to go into edit mode, I simply press enter, and then I can do some sort of code and execute it like that, and so forth. So I can keep adding cells above with A. Now notice I'm in command mode. I can add cells below the current cell with B. So now I'm adding a bunch of cells like this. And I've added quite a few cells. Oh, one other thing that's not on here is that the arrow keys, when you're in command mode, just go up and down these cells like that. So you can use your arrow keys to do this. I really like having my hands on the keyboard and not using my mouse to move around. It really helps speed things up if you can keep your hands on the keyboard and not have to use your mouse to place yourself in a particular position. So A inserts cells above, B inserts cells below, X deletes cells, or really cuts them so you can actually paste them later, but it's just a one command to delete. So I'm going to press X here, and you should see that it is deleting cells, so that's a very important one. And lastly, you can press M to change a cell into a markdown cell, and then Y to change it back to a code cell. So I'm going to press M right here, and notice that I now am in markdown. That in is gone. There's no execution number, and we will be writing some Markdown here in a second. I can press Y to get back to a code cell. Now there are more commands over here, keyboard shortcuts, and the way to see them is you can go here to the help menu, and you can look at these keyboard shortcuts like this, and you can see here all the ones in command mode. Obviously I did not cover all of them, but the ones I showed you are the ones I use more than 90% of the time. These are all the most commonly used ones. There are also keyboard shortcuts in edit mode. These are typically the ones you already know how to use, like Command A will select everything. Control C just copies, Control V pastes. But there are a few more that are specific to the notebook, so you can look at those. So those are available in edit mode. But most of the shortcuts I use are in command mode and the ones over here. Okay, so let's move on. So you need to know how to get help in the notebook. So the notebook, you don't necessarily want to be looking things up. There's a lot of help provided in the notebook itself. So I want to show you two things that I use all the time. So let's say I have some string in Python that I've assigned to S. So what you can do is use tab to list all the possible attributes and methods. So let's just say we want to do something to the string. You know that Python is an object-oriented language. It has many methods that follow the dot. So you place a dot after the variable name, and then you press tab. So tab helps you discover all of the methods. So these are all of the methods. They will pop up in a drop-down menu as such. So that is helpful. And then let's just say we want to pick a method. So let's just say we pick the count method, but we want to know how to use this. So once you've picked your method, you can view the documentation with holding down Shift and pressing Tab twice. So once and twice, and this will bring up the documentation in a pop-up menu like this. So this is a great tool. I use it all the time. I'm constantly pressing Shift, Tab, Tab. You will see that when I'm going through the material. It really helps out understand the methods. So I like to call the first one is discovery. That's how I find out what are the possible things I can do. And then usage, how do I use that thing that I just discovered? I press Shift, Tab, Tab. So these are two important things to keep in mind as you're working through the material in a notebook. Now, lastly, I'm going to cover just a very quick introduction to Markdown. I'm going to show a couple of different things you can do, and these are just the most common things that are available in Markdown. First, I'm going to convert this to a Markdown cell. I'm in edit mode, so I'm going to change this to command mode by pressing escape, and then M for Markdown. Now I'm in a Markdown cell. I'm going to press enter to go back into edit mode, and now that we see the cell is highlighted in green, I have marked a cursor over here. So now the keys, when I type them, are just displaying exactly what they are. So just like code cells, you have to press Shift Enter to execute the Markdown cell and then to render it. So I'll say this is a Markdown cell. So it understands plain text. And if I press Shift Enter, I will execute this. And this is what it renders. So I didn't add any special styling just yet. I just said this is a Markdown cell, and it rendered exactly what it showed. All right, now I'm going to go back into edit mode, pressing enter. And the two things I want to show you are just how to make text larger as a header. So the way to do this is to precede the beginning of the line by a pound symbol and a space. So you need a space, and the more pound symbols you use, the smaller the text will be. If you're familiar with HTML, they correspond to H1 to H6 headers. Let's just make the largest header like this and press Shift Enter. So here is what it will render as, a nice header. And let's go back into edit mode. The next thing I'm going to show you is how to make lists in Markdown. So you have to begin a line with a star, and this is how you create a list. So, Markdown is a simple language. We can make that as the first item, and Python code goes in the code cells. Okay, now if I press Shift Enter, it will render these two things as bulleted list items like that. So this is a great way to use Markdown as you're going through the material to add your own notes, or whenever you create your own notebooks, you can add Markdown like that. Now there's several more things to Markdown, like how to add images or links and so forth, how to make things bold or italic. That's actually covered in this PDF that I provided to you. You can also just write in plain text like this and write whatever you want, and that'll just show up as a normal paragraph of text. Okay, so that's all I have for you for this introduction to Jupyter Notebooks. Hopefully you will go ahead and practice and also read this introduction PDF over there and get really good at using the Jupyter Notebook to your benefit. In this video, I'm going to show you how to work through the material in a Jupyter Notebook. So I've opened up my terminal and already changed directories to where the course is located. I'm now going to just launch a Jupyter Notebook, and this will drop me right into the middle of the course contents. So let's go ahead and go into Jupyter Notebooks, which is where we'll always go. And let's just say we're in Intro to Pandas, and let's pick one of these notebooks. Say we're in chapter 4, setting a meaningful index. So one thing you'll notice when you open up the Jupyter Notebook is that none of the code cells are executed. So you're going to have to execute the cells as you go along. So this will keep things interactive. So you will just go from top to bottom. You will read the text, then you'll execute the cells and so forth. And then at the bottom of the notebook, you will see some exercises. So you'll want to answer these exercises, and then I'll show you where the solutions are found. But so it's pretty simple. But what I wanted to add was that during the cover, as you are going through the notebook, you can add cells in here. So we remember how to add cells by pressing A in command mode. You can go in here and write your own code. Over here, some code like this. You can also add your own notes, so you can edit these notebooks and write these are my notes or something, and then write some notes in here. Now if you don't want to disturb the original notebooks, you can of course just make a copy and then work out of there. But these notebooks are meant for you to edit, write your own code, to experiment. Feel free to do all that as you are going through this material. Now I suggest reading through the material and then watching the video, but just doing both should be very beneficial. Okay, so that's how I would go through these notebooks. And then at the end, just make sure you answer the exercises at the bottom of the notebooks. There's almost always exercises for each notebook. And what is also very beneficial is looking at the solution. So in every part of the book, there will be a solutions notebook, and we can just open that up. And here will be the solutions, and you can just click on the title and you can see the solutions down here. Now even if you believe you got some of the exercises correct, it's still good to look at the solutions because you might see a different way and perhaps a more effective or efficient solution. All right, so hopefully that helps you get through or understand how to go through the material in a Jupyter Notebook. In this video, I'm going to discuss the differences between your notebooks and the notebooks that you see in the videos. So the videos will cover the majority of the material, but not all of it. There's just so much material in your notebooks to cover that it's not quite feasible to do a video on every single item that appears in the notebooks. Another thing is that the notebooks in the videos will have a lot of the text removed like this, and you'll just see these headings. There'll also be a lot of code removed so that I can write the code live like that. So those are the major differences. So when you see the video notebooks, you'll see that they don't match the notebooks that you have, and that's on purpose so that you can just concentrate on looking at the code and just some of the headers and not try to read all of the text on the screen at the same time. So it helps you just focus on what is the main part of the lesson. We're just about to begin, but I want to cover one more item, and that's when to open up a new notebook. So for the vast majority of notebooks, there will be multiple videos associated with it. It will take often several videos to go through the notebook. So the way that it works is that part of the notebook will be covered in one video, and then the next part in another video, and so on. So you'll know when to open up a new notebook, obviously whenever we're at the very top, and I say something like, welcome to notebook number 5, blah, blah, blah. So just to keep that in mind, you're not going to be opening up notebooks at the same rate that you are going through videos. Welcome to What is Pandas? This is the first notebook in the Intro to Pandas part. So what exactly is Pandas? Well, it's a popular open source Python data exploration library that gives its users the power to explore, query, transform, aggregate, and visualize data, amongst many others. So why are we going to choose Pandas and not some other tool for data analysis? Well, there are many other tools just as capable as Pandas for completing data analysis tasks, but there are also many reasons that make Pandas an attractive choice. Number one, it's a Python library, and Python has become one of the most popular programming language today. And if your goal is to analyze data programmatically, which is what Pandas helps you do, then often you'll choose Python as your language, and then Pandas is the most popular tool within Python to do data analysis. There are also many other ecosystems within Python to help you do data visualization or machine learning or just any other scientific computing task, and Pandas integrates well with these other libraries such as NumPy, scikit-learn, StatsModels, Matplotlib, Seaborn, and many others. Another reason is that Pandas is nearly self-contained, meaning that there's lots of functionality built into a single package. So if you do have some specific data analysis task, Pandas is almost always capable of completing it, and there won't be much of a need to import other libraries to do the tasks that you're wishing to complete. It's also easy to get help. So you're often just a quick internet search away from finding a solution to a data analysis task using Pandas. And if a specific task you can't find help for, you can use sites such as Stack Overflow, where questions are often answered very quickly, as there's just so many people that know Pandas and are experts at it and are willing to provide you the exact help to your specific problem. Looking at the name, you'll probably be reminded of an East Asian bear, but that's not where the term Pandas comes from. Pandas was created in 2008 by Wes McKinney while working at the hedge fund AQR. And it's common in finance speak to use the term panel data to refer to two-dimensional data, which is what Pandas analyzes. And if you smash together panel and data, then you'll come up with Pandas. You're likely aware that Python already has data structures to handle data, and you might be wondering why we need Pandas. So the built-in data structures, such as lists, sets, tuples, and dictionaries, are not built for scientific computing. They are general-purpose data structures that can handle many different types of data, and they are not optimized for the type of operations that are necessary when doing scientific computing. Another library called NumPy, short for Numerical Python, does have a data structure called an array, which contains homogeneous data and is optimized for scientific computing. The Pandas library is built directly on top of this NumPy library and just adds considerable more functionality that is common to people doing data analysis. One thing to note is that Pandas operates on tabular data. This is the regular two-dimensional data of rows and columns that you typically see, rectangular shaped, otherwise known as a table. And Pandas is able to read in many different formats of data, such as XML, JSON, CSV, Parquet, and many others. And when Pandas reads in a particular data set, it will always return it as a data frame. The data frame, along with the series, are the two primary Pandas objects that contain all of the data. We will go deep into both of these objects. So specifically, a data frame is a two-dimensional data structure that looks like any other rectangular table of data with rows and columns. A series is just a single dimension of data, and it's analogous to a single column of data in a table or a one-dimensional array. So some resources for you. The Pandas documentation is very good and could be open at all times while you're going through this course. It's available at pandas.pydata.org. And then, of course, the videos in the Master Data Analysis with Python series. This is an extremely comprehensive path for learning Pandas. There's hundreds of exercises and projects for you. Welcome to the second video in the What is Pandas notebook. And in this video, we're going to discuss which Pandas version to use. So we're just about to import Pandas and use it for the first time, but we need to make sure that we have at least Pandas version 1.0 and preferably just the latest version. So the reason for 1.0 is that the previous version, 0.25, there were some major changes between those versions that you just must have in order to complete the course. All right, so let's see how we can find which version of Pandas we have. So we do that by importing it. We will always alias it as PD by convention. And then to find the version, we do PD dot double underscore version double underscore. And this will return a string of the version number. So there's three components to a version number: the major, minor, and micro components. So this is version 1.3.4, major version 1, minor version 3, and then micro version 4. We usually don't say the micro version. These are just for small like bug fixes, so this won't affect things very much. The minor version is actually important because there are new things added to the library and sometimes things removed. And then for major changes that it will actually break code is when the major version will change. So we're now on major version 1 and minor version 3. Now, if you don't, to upgrade, what you'll need to do is go to your command line. And so do not do this in a Jupyter notebook, but I'm just going to show you what you write. If you're running Conda, then you simply will execute conda update pandas like that, and this will get you up to the current latest version. If you are not using conda, which is fine, you can do pip install -U pandas like this. This will just stands for upgrade, and it will update to the latest version as well. Okay, so that should help you get started and find out and figure out which version of Pandas you can run. Welcome to the next video from the What is Pandas notebook. In this video, I'm going to show several different Pandas examples from different parts of the library. This will just be a small sampling of the total available data analysis tasks that Pandas can complete. I just want to give you an overall view of some of the things that Pandas is good at doing. Now notice in this video, the idea is not to explain the code, that's for the rest of the course, but to just give you a sample of the things that Pandas can do. All right, so let's get started by importing Pandas, aliasing it as PD. Here I'm going to read in a data set of bike rentals, so each row represents a single bike rental. This is a data frame. And one of the simplest things that you'll probably want to do with data sets is to query or just filter for specific rows that meet a specific condition. In this case, the condition is that the trip duration will be greater than 5,000 and that the gender will be equal to the string female. Let's go ahead and look at the first three that match this criteria. And there they are, so you can double check, verify that they match. Pandas can also aggregate values very easily. So the definition of an aggregation is a sequence of values that is summarized by a single number. So let's take a look at this data set, which contains salaries from employees. So each row is a single employee with their salary. So let's say we want to aggregate the each column and summarize each column by the mean. So we'll take every value in that column, take the mean, and then report that. So Pandas can do that easily with this. And what is returned, you can see here, these are the mean values for each of those columns with a simple single line of code. You've just aggregated each column independently. Moving on, Pandas has non-aggregating methods, such as the round method, where each value is rounded and then returned a value. So we're not summarizing the columns, but we're just changing each value. So we're going to round to the nearest 1,000, and that's done by using -3 like that. And so here we go, we've rounded each value to the nearest 1,000. So we previously just aggregated over the entire data frame, but we might want to aggregate within groups, and Pandas has that capability. So instead of just taking a column such as the charges column and finding the mean of it, we can find the charges within groups of another column. So in this case, we're going to look in the sex column and find all the unique values of sex. Those will each be groups. And then we will find the mean charges for all those different groups. Let's go ahead and execute this right here. And we can see that we've gotten two different mean values of charges because there are two different groups. All right, moving on. If you've worked in Excel, you've probably worked with pivot tables. So Pandas has this as well. In this instance, we're going to pivot the sex and region column. So the unique values in the sex and region columns will form these groups. And then we'll do the same thing we did above and just find the mean charges for those groups. So for instance, the females in the Northwest region have this average charge and so on. So that's a pivot table in Pandas. Now, if you're delivering a report, say in a Jupyter Notebook, you might want to change the style of the outputted data frame, and you can do that in Pandas. And here's an example with a couple of style changes. We've highlighted the maximum value in each column over here, and we've also formatted the data such that there is a comma for the thousands place. All right, Pandas can also join data together. So in this example here, we have some authors in one table. We have these machine learning papers in another table. And let's say we're interested in finding the author from each of these papers. So say over here in the first row, we want to find out, okay, who is the author of paper ID 5677? Well, we can join these tables together in Pandas with this merge method like this. And so now I know that the author of 5677 is this person right over here. Pandas is fully capable of doing time series analysis. Here is Microsoft stock data, 20 years of it. So one cool thing that you can do here is you can select a very specific time period pretty easily. Here I've selected these 4 days, just like that. So we're just selecting a very specific period of time just to focus our attention on it. We can also group by time, so which is also fairly interesting. So let's say we want to average all of the closing prices for each month of the stock. That's what we do here. So for each month, there will be an average price for all of the closing prices in that month. Pandas is also capable of producing visualizations from its data frame. So down here, we're just going to take the Microsoft monthly chart and plot it as a line plot like that. And in this line, we will plot the pivot table that we created above with the insurances divided by sex and region. Okay, so that is, again, just a small sampling of what Pandas can do. There are many, many more tasks that it can complete, and we will begin learning them in detail in the next video. Welcome to notebook number 2, the data frame and series. So the data frame and series are the two primary objects when using pandas to analyze data. A data frame is a two-dimensional table of rows and columns, while a series is a single dimension of data. So how do you get one of these data frames or series? Well, you can create your own by hand, but that's very tedious and uncommon. What's more common is that you'll read in data from some file. Now, Pandas gives you many different tools to read in data from all sorts of different file formats. We're not going to cover that here. There will be sections later on in this book that cover that. The focus here is going to be on the data frame and series itself. So one of the most common ways to read in data is with this read CSV function in Pandas. It's able to read in these plain text files where each piece of data is separated from another by some delimiter, and usually this delimiter is a comma. That's where the name CSV comes from. And we're going to read in this City of Chicago bike rides. Now before we do that, I want to take a look at the raw data file itself. So this is just some pure Python over here that iterates through the first 3 rows and just prints them out to the screen. So let's take a look, and you'll see that here are the 3 different rows. And if you look closely, there are commas that separate each piece of data like this. Now the way that most CSVs are formatted is that the first row is the columns of the table. So you can see how that row is significantly different than the other 2. The other 2 have the actual data that you care about. So this is a pretty typical CSV, each piece of data separated by a comma. Now we're going to read in this data into a Pandas data frame, and we're going to use this read CSV function. Now there are many options in this read CSV function, but we're not going to look at them just yet, because again our focus is going to be on the data frame and series itself. So what I'm going to do is now I'm going to actually use Pandas. I'm going to import it in, alias it as PD. I'm then going to use this read CSV function, passing it in the location of the data set like this as a string, and the data frame will be returned as the variable bikes. Let's go ahead and execute this. And so it is successfully read it in. We cannot see this, what bikes is, because we have an assignment statement. This is no different than if you assign A to 5. In order to view the actual value, you have to put the variable name in a cell by itself, or just put it in the bottom of a cell. And that's how you can actually view the value. So we still haven't seen our data frame. We don't even know it's a data frame, but we can verify this with the type function. And if we just pass in the data frame name like this, we can verify that indeed it is a data frame. So the type always comes at the end. This is called the fully qualified path name, where you have the package name and then sub packages, and then finally the class name at the very end. So this is indeed a data frame object. Now let's go ahead and view this data frame by putting the name in a cell by itself and executing this. So by default, Pandas will show the first 5 and last 5 rows. This data frame has 50,000 rows. It has 11 columns. You can see all 11 of them. By default, if they're more than 20, then it'll just kind of cut some of them off. It's important to note that this is just a display of the data frame. There are 50,000 rows, and we're just getting a visual representation of 10 of them. You can see the little dots over here indicating that there's more data. So the data does exist, you just don't get to view it in your notebook. Pandas smartly just has a limit on what is viewable, and we can change these limits later if you want to see more of the data. But that is what you'll see by default when you put a data frame and look at it in its own cell. Okay, so the first methods that we're going to cover here are the head and tail methods. I believe these are very important and very simple methods. So the head method will just show us the first 5 rows of the data frame by default. So the head, of course, so these are just the first 5 rows. This is often what you'll want when you're doing a data analysis. You don't have to look at all of the rows. You'll just want to look at the top just to make sure that the result is what you want, and then move on. Now there is a single parameter you can pass here, and it is n. You don't have to specify it usually. So let's say I want to look at only the first three. Well, I can do, I just put that n in there and get that. Similarly, the tail method will return the last 5 rows by default. So there they are. And again, you can put in any other number you want, and you'll get that exact number of rows returned. All right, so that is just a very quick intro into the data frame and the head and tail methods. We'll go much deeper into the rest of it in the following videos. Welcome to the components of a data frame. There are 3 distinct components that you must be aware of: the columns, index, and data. So if you take a look down here at this styled data frame, you'll see that the columns are in green above, the index is in red to the left, and the data is just everything else over here in this bluish purple color. So you might not think these look like distinct objects, but it's important to think of the columns and the index as these distinct objects that label values. So let me tell you what that means. If you take a look at, say, this start time column, this start time column labels each one of these values that come below it. Just like this trip duration column labels all of these values over here. So it's like a reference that will point to all of the values below it. So if you take a look at the index, you might think of it as just not really even attached to the data frame, but it is actually very important. It has the same role as the columns, but it does so for the rows. So this label 0 over here labels all of the row values of the first row. Just like this integer 3 over here labels all of the values in this row. So by default, pandas will use an index that begins at integer 0 and continue from there. But as we'll see later on, the index can be strings as well. So it's not just stuck with integers, and it looks quite benign over here when it's integers and meaningless, but it does actually have a very important role and very important meaning. It's basically the same as the columns, but for the rows. Now, one other piece of information is that you can think of the data frame as like a coordinate plane where you have an X and Y axis. So Pandas also has this idea of an axis. There are 2 directions, and the columns are given axis number 1, the integer 1, and index as axis 0. So these will come up a little later. You don't have to really worry about that now, just so that you are aware of it when we do reach these axis numbers further on in the course. Okay, so let's take a look at the bikes data frame in an actual notebook, not just styled like that. So the columns will be bold and on top of this line over here, so they'll be very distinct. And just as we talked about earlier, each one of these columns is a label for all the values that follow below it. And then over here you can see the index, and again it looks like maybe just quite meaningless, but it is an important part. It just happens to be that they are integers. So this integers 2 labels this entire row right here. Okay, so those are the 3 distinct components of a data frame: the columns, the index, and then everything else is called the data, or otherwise known as the values. In this video, we're going to select a single column from a data frame which will return a series. So let's go ahead and look at our bikes data frame again. Let's look at the first 3 rows. Now this is a data frame, and that's what will be returned when you call the readCSV function. Now you might be wondering, well, how am I going to get a series? Well, the way to do that from a data frame is just to simply select a single column. So we'll look over here, and we'll use the square brackets attached to the data frame. So directly to the right of the data frame, we're going to place these square brackets, and inside of here, place the name of the column. In this case, they're all strings. So let's say we want to look at the trip duration column like this. This will select that column as a series. So notice this is a much different, it looks like a much different element, and it is not styled like a data data frame. This is what is known as a series. I will assign it to some variable s like this. So when I assign it, there will be no output. I can add another line in my cell and say it also has the head and tail methods, just like data frames, and we can print out the first 5 rows. So that's how you select a series, and we can verify that this is in fact a series with the type function. Let's go ahead and do that now, and you can see that indeed it is a series. All right, so that's how you select a single column from a data frame, which will end up being a series. In this video, I'll complete the exercises at the bottom of the data frame and series notebook. We're going to use the bikes data frame. Exercise 1. Select the column events, the type of weather that was recorded, and assign it to a variable with the same name. Output the first 10 values. All right, so we'll create a variable called events. We'll go into the bikes data frame, use the square brackets to make the selection of the column, place the column name in those square brackets, which happens to be the string called events. That'll select the column as a series, and then we want to output the first 10 values. Okay, so that does it. So here's our series of the first 10 values. Exercise number 2. What type of object is events? Well, it is a series, but we need to formally verify, passing it into the type function, and we can see that it is indeed a series. All right, exercise number 3. Select the last 2 rows of the bikes data frame and assign it to the variable bikes last 2. Okay, we can do that. Bikes last 2 equals bikes tail. That's how we select the last 2 or last 5 rows. We can put in 2 to make it just the last 2 rows, and then we'll output the data frame. So it's a data frame. It's not a series of 2 rows with all of the columns. And yes, we can verify is in fact a data frame, but it does have 2 dimensions, rows and columns, so we know just by looking at it, it is definitely a data frame. All right, so that does it for the exercises. I'm going to show you a few ways of getting help in a Jupyter Notebook. I'm going to show you how to use tab completion for the columns, how to use tab completion for the attributes and methods, and then how to use Shift-Tab-Tab to bring up the documentation. So let's go ahead and look at our data frame like this. Now, one tip that I use all the time is to select a single column. So let's say I've opened up these square brackets and I have a column name that is a string. I begin my string and then I start typing out the column name. So say from station name, and I just type in the first few characters. Then I press tab, and all of a sudden it will complete the column name for me. So this is a great way to ensure that you are spelling the column name right. So the tab completion will help you with that. If you have, let's just say, a column where there are multiple of the same, or there are multiple potential columns that it could be, you press tab and you will get this little drop-down menu, and then you can just select the column that you want like that. All right, so that is one way to use tab completion. Another way to use tab completion is when we look more into attributes and methods. So far, we've really only looked at the head and tail method. So if we press dot right here and then press tab, you'll get a list of all of the attributes and methods that are available to a pandas data frame. There are an enormous amount, over 200. Thankfully, only a smaller subset of these can be used to basically give you all the power in pandas. But regardless of that, this is a very nice way to bring up all the available attributes and methods to your data frame. If you start typing out your whatever method you're trying to use, it'll just narrow down, and then you can search for it in the column, or search for it with your arrow keys and find the particular method that you want. All right, so let's just say we've picked this core method. Let's find the correlation. Now, so you've picked a method and you want to figure out how to do it. Now, you can obviously look this up online, but you can also stay in the notebook. So once you've discovered this attribute or method, you can press Shift-Tab-Tab. So hold down Shift, press Tab once and then twice, then you can let go, and it'll bring up the documentation. So it'll show you all the different parameters It'll give you a description of what the method does, and then I'll talk about what are the possible values for those parameters. So you'll see me doing this all the time within the lessons. I will not be verbalizing that I'm doing Shift Tab Tab. So you should just know that when you see the documentation pop up, I've pressed Shift Tab Tab. So these are the three things that will really help you work through a Jupyter Notebook and work in Pandas. Use tab completion for the columns, use tab completion to discover the attributes and methods, and then use Shift Tab Tab to bring up the documentation. In this video, we'll complete the exercises at the bottom of the data types and missing values notebook. So exercise 1, what type of object is returned from the dtypes attribute? So we already discussed this. So the dtypes attribute, we see that it returns, looks like a series, but just to verify, we can pass it to the type function, and we see that we do in fact have a series. So that's pretty cool. You can actually save the output of the dtypes to some value like S, and then you can look it up later. All right, so what type of object is returned from the shape attribute? The shape attribute, and I mentioned this, returns a tuple, and again we'll just verify that in fact we do have a Python tuple. All right, so that does it for the exercises. Welcome to notebook number 3, data types and missing values. We'll begin by discussing the different types of data found within data frames and series. So each data frame column has a data type, and likewise each series has a data type. Now there are many different data types found and available in Pandas, but these are the most common ones. So there are Booleans. These are only two possible values, true and false. Integer, these are whole numbers without decimals. Floats, these are numbers with decimals. The object data type is the most confusing and most peculiar one. So these are typically strings, but technically can contain any Python object. So more on this a little bit later. There are date times. These are specific date and times with nanosecond precision. Now, why is it important to know the data type of each column? Well, I think it's extremely important because if you know the data type of a column, then you are guaranteed to know the data type of each individual value in that column. So say you have a column that has the integer data type, that means every single value in that column will also be an integer. So it gives you some idea of what to expect in that column. Now this isn't true for this object data type, that's the only exception, and why this can cause confusion for some people. Now, like I said before, when you see the object data type, it is almost always going to be strings, but it could be other objects. There could be lists in there. It could be a mix of integers, floats, strings, date times, whatever. But for the most part, you're going to see strings there. Now, this was a major problem when Pandas was first released. So what they did do is there is a new string data type. This was a major enhancement to Pandas 1.0. It is still considered experimental, but this is a good move forward in Pandas. And eventually, when we get to future versions of Pandas, we'll only use the string data type and not have to deal with this confusion of this object data type. All right, so moving on, there are different missing value representations in a Pandas data frame or series. There are two main ones. So when you see NaN, this stands for not a number, and NAT, this stands for not a time. You'll see the not a time inside of the date time columns. The not a number you'll see in the float columns. And unfortunately, this is also another limitation in Pandas and just a consequence of, when it was first built. There is no missing value representation for Booleans or integers. So if we look down here, Boolean and integer columns have no missing value representation. So if you have a Boolean column, then you're guaranteed to have no missing values in there. And likewise, if you have an integer column, then you also will not have any missing values in there. Now, this was also a problem that needed to be rectified and was dealt with in Pandas 1.0. There are new data types called the nullable integer and nullable Boolean. These are also experimental, and these are not the default data types. So if you read in a column from a file,
like a CSV file and it does contain booleans but also missing values, then it'll convert it to another type such as float or object, just so that it can actually read it in. So that's somewhat unfortunate, and more detail into data types will be covered further along in the book. So this is not the last discussion on data types. This is just an introduction to data types and missing values. So it will be a very detailed discussion later on. So my recommendation for now is to avoid the new data types. And while they can work out well, the developers are still working out the kinks in them. They're also not the default data types. So whenever you read in a data frame, you will not get these new data and improved data types. You'll be stuck with the original data types. So until they have made the defaults maybe in Pandas 2.0, then I would probably just stick with the current older data types. One other thing that was introduced in Pandas 1.0 was that there was a new missing value representation. So this got rid of all the other missing value representations, nan and nat. There'll just be one going forward, and that makes a lot of sense to me. It is this is just a straight from the pd.na. That's how you find it. And again, this will be brought up again in that data types section. So this is also experimental, but does unify all the missing values into a single object. All right, so that's a brief introduction into the data types and missing values. We will go into and see them with actual data frames in the next video. In this video, we'll be finding the data type of each column. So we're going to go ahead and read in this bikes CSV again, like we've done before. I'm going to assign it to the bikes variable and output the first 3 rows. So here we have the first 3 rows in every single column. Now, one of the first things I like to do after I read in the data set is to find out the data type of each column. So this is, like I said, very important. This tells you a lot of information about the data that you have. So it's vital to have this information, and the way you obtain it is with this dtypes attribute. Notice that this is not a method. There are no parentheses that follow it. Let's go ahead and run this, and what it'll output is just the data type matched up with each column. So it gives you that information very quickly, very nicely. Now, one thing to notice here is, before we actually talk about the data types, is what has been returned, and hopefully you recognize this object. It is a Pandas series. So Pandas uses its own series object to return this information. So each column name is now in the index. So this is the first time that we're seeing strings in the index. So each column is now a label for the data type itself. So we see we have a lot of object data types. So the gender column is object. And remember, I said that object typically refers to strings, but could actually have any object in there. But for the time being, we're just going to assume that whenever we see object, it will be a string column. So the first 3 are objects. Trip duration is read in as an integer. I'll cover what this 64 is a little bit later. We have some float columns over here and a couple more object columns. Now, one thing you might be wondering is that, all right, why are these start time and stop time read in as objects and not as date times? Well, Pandas doesn't, it could have some logic to inspect these, but you have to force Pandas into converting these into date times upon read. So this is one instance where I will show a little detail into the read CSV function. So if you do have a date time, Pandas will not read it in by default as a date time. What you'll have to do is go in here and use this parse dates parameter. In the read CSV function, you always set it equal to a list of all the columns that are date times. So here I'm going to set it equal to start time and stop time, like that. So now it knows that whenever it sees these 2 columns, convert it to date time. Do not keep it as a string. Okay, so let's go ahead and do that. And we can just output the result. You'll see that it looks the exact same, the appearance, but if we look at bikes.dtypes again, we'll see that now it is converted to a datetime object. So that's exactly what we want. So if we have date times, we want to make them a datetime object and not keep them as just a regular object. You might be wondering if there's any difference. Well, there actually is quite a lot of difference. There's a lot of functionality specific to datetime columns. So if you don't convert them to a datetime, then you don't have access to that functionality. All right, so one other note is, why are these 64s appended to integers, floats, and date times? This stands for the bit size, so int 64, float 64, datetime 64. These are all 64 bits. They can handle 64 bits of information. So for integers, this means that they range from -2 to the 63rd all the way up to 2 to the 63rd. That if you add those together, that equals 2 to the 64 possible combinations. You can actually, if you write this out, you can actually find the maximum integer like this. So it's very close to whatever this number is. Same if you do and just convert it to a negative to find the lowest integer. So it can handle all integers in between this range. Integers outside of that range, it will not be able to handle. For floats, there's a different mechanism for finding the max and min, but there's a huge range. Actually, I believe it's up to 1 to the, or e to the -308 or something like that. So there are ways to find out the max and min float. I'm not going to cover it now. It's not super important. Same thing with the date time. It can cover a range of, it's the same range as integers, but just as date times up to nanosecond precision. So again, there will be more detail on the all of these data types further along in the book. The point right now is just to be aware of what the data types are. Okay, so so again, what we found out is that the dtypes attribute is how you get the date time, or how you get the data types, and is what I typically call right after reading in the data. This is one of the most important pieces of information to have about your data frame. In this video, we're going to discuss getting more metadata. So what is metadata? Well, it's just data on the data, and these examples should help explain what it is. So actually in the last video, we got some metadata by finding the data types of each column. So here we just get them again. Now, one of the next pieces of information that I want to know after I read in a data set is just the total number of values that I have. How many rows and columns is the data frame? So to do that, we access this shape attribute. Again, this is not a method, so we're not calling it here. There are no parentheses. This will return a Python tuple of the number of rows and columns. So about 50,000 rows and 11 columns. Now there's another attribute called the size attribute. I don't use this one that much, but it returns the total number of values in the data frame. So that's just the number of rows times the number of columns. Now there's another way to get the number of rows, and that's with the len built-in function. So you might be wondering how this works. What is the length of a data frame? It's 2 dimensions. Well, just by default, you just have to know and remember that it'll just return a single integer, and that's just the number of rows. So it's just another way to get the number of rows without having to go through bikes.shape first. Of course, bikes.shape is just a tuple, so you can just get the very first value like that, and it's the same exact thing. Now there's a function, or sorry, a method called the info method, and this is pretty interesting. This gives you lots of information about the data frame. It will look like the output of the dtypes attribute, but here so it does show the column and the data types like this. It also gives you information on the number of the columns. It breaks down the columns, it counts them by data type. So it says, all right, you have 2 date times, 4 floats, 1 integer, and 4 objects. It covers the index, so we'll cover this range index a little bit later. It also tells you the number of non-missing values. So we know that there's 50,089 total values, but if you look down here, we do have a couple of columns that do have less than that total number. So we know that these columns do have some missing values. Perhaps it would have been better if it just showed us the number of missing values instead of non-missing values, but That's what it shows. The object that is on your screen is actually just printed information, so you can't assign this to anything. This is not a data frame. It is not a series. It's one of the few times where it'll return nothing but just print information to the screen. It also shows you the amount of memory used, so you can see how much memory is being taken up. This is important when you have very large files and want to know how much of your system memory is being taken up. All right, so that is how we can get some more metadata. In this video, we'll complete the exercises at the bottom of the data types and missing values notebook. So exercise 1, what type of object is returned from the dtypes attribute? So we already discussed this. So the dtypes attribute, we see that it returns, looks like a series, but just to verify, we can pass it to the type function, and we see that we do in fact have a series. So that's pretty cool. You can actually save the output of the dtypes to some value like S, and then you can look it up later. All right, so what type of object is returned from the shape attribute? The shape attribute, and I mentioned this, returns a tuple, and again we'll just verify that in fact we do have a Python tuple. All right, so that does it for the exercises. Welcome to notebook number 4, setting a meaningful index. So in this video, we're going to be setting an index of a data frame. Now before we do that, let's go ahead and read in a new data set. This was the sample data CSV. It's just a few rows of some fake data. Now whenever you read in a data frame, it will always have an index and columns. You can never have a data frame that does not have both. So the index over here looks meaningless, but it is significant. It is just the integers beginning at 0, but again, they act as labels for the rows, right? So index or integer 2 labels this entire row, just like integer 5 labels this entire row. Now the columns are easier to distinguish because they are strings. The column food labels all of the values in this column. Now, I want to talk about how you can change this index to something a little bit more meaningful. So the way to do this, and one way to do this, is with the setIndex method. And typically, when you set an index, you're going to choose a column in your data frame to use as the index. So, one way to choose is to find a column that uniquely identifies the row, and that really signifies that row and gives it some meaning. Here, we're just going to use this first column, the name column, like this. And obviously names can repeat, but they don't for this small data set. And we'll just call this method like this. So you have to pass it some column name like that to choose as your index. So when we do this, we see that the data frames look almost identical. The only thing that's happened is that now this name column is bold. Now name is no longer an index, name is no longer a column. It is the index, so it is a separate component of the data frame. Now these strings uniquely label the rest of the values. They are not part of the values themselves or the data. They are labels now. So one confusing thing in pandas to realize is that most methods return an entire new copy of the data. So what that means is that this data frame that we just produced was not assigned to any variable, and therefore we cannot access it again. So if we look at df, again, this might surprise you, you'll see that it has its original index. Well, that's because we didn't modify the original data frame, which was referenced by this variable name df. So what we have to do is assign this command, the result of this setIndex method, to some other variable name. So if we do that, like say df2, then we have a reference to this new data frame that has this name column as the index. So here we have df2, and now this actually has what we want with our name column in the index. df, again, is still going to be this. It has not been modified. So there are very few methods that will mutate a data frame in place. So that if this did change df, you would say that it has been modified in place. Now some methods, such as the setIndex method, does have an in-place parameter. And if I press Shift Tab Tab, you can see that there is an in-place parameter. So if we set that equal to true, then it will modify it in place, and we would not have to assign the result to anything in order for it to keep that change. But by default, it doesn't. So in that case, we must assign it to a new variable if we want to reference that changed data frame or that new data frame. All right, so that's it for setting an index. Pretty simple. Just pass a string column name into this setIndex method, and that will pop your new data frame with that column as the index. In this video, we'll be accessing the index, columns, and data. So let's take a look at df2 again, which contains our new data frame with the name column in the index. So as I said earlier, the data frame is composed of three components: the index, columns, and data, and you can access them as attributes. So let's go ahead and look at the index. So in this case, it'll return an object called the index object. Now, I should say that it's not very important to understand the index object at this point. You will be working with the data frame as a whole, and not typically with these objects. I'll cover them when needed, but I don't want to sidetrack and go down what this object is. For now, you can think of it more or less as a list that contains a sequence of values, and here we just have a bunch of strings like this. So that is the index over here. Now the columns are just accessed by the columns attribute. Again, these are not methods, so there's no parentheses over here. These are attributes. And we see here it looks very similar as the index object. In fact, it is also an index object. So Pandas uses the same underlying object for the columns as it does for the index. And it's this capital I index object. And again, it looks like a list of the column names as strings. Now, to access the underlying data, there is no data attribute. It's actually the values attribute. So that might be a little confusing to know, but this just extracts just the values themselves without the index and without the columns attached. And actually it returns a NumPy array object. So Pandas is built on top of NumPy. So this is a two-dimensional array object, and it is just the values. There are no labels for the rows and no labels for the columns. You can think of you can access the rows by integer location, like 0, 1, 2, just like any other array. But there are no labels anymore attached to it. All right, so accessing these individual components does not change the data frame at all. It just means that you can separately access the components using those attributes. So df2 will still be a data frame. It'll still all be intact, but you can, if you want, say I want to get the value of this index or this column name. You can certainly do that, and you can also just get the values as a NumPy array. Okay, so it's more typical to be working with the entire data frame. Right now it's going to be somewhat rare to go down into the index and columns and values, but I just want to let you know that it is possible, and we will access them occasionally, and I think you'll understand when we get there what is happening when we do access them. We'll be accessing the components of a series. Let's look at our data frame again, and we're going to select a single column as a series. Let's go ahead and do that. So we'll select the color column, and let's output it, or let's assign it to the variable name S. So here we've accessed this color column. Now, one important thing to note here is that whenever you select a single column from a data frame, the index comes along with it. Even though you didn't select the index specifically, we selected the column color, but it still has the same labels attached to it. So it doesn't result or revert back to the default index. That's a very important thing to note. All right, so now we have a series. It's a simple series that has these name strings as labels, and then here are the actual values. Well, we can select the two components of a series. So there are no columns, but there is an index. So it's going to be the exact same index as the data frame. And then the values will just be these values over here, and it'll be in a one-dimensional NumPy array like that. So again, the series, nothing happens to the underlying series. You can just access each of the components individually. In this video, we'll cover the default index. So whenever you read in a data frame, it will always have an index regardless of whether you set one or not. So in this cell, we're going to read in the movie data set, which contains lots of information about many different movies. Displayed is the first 3 rows. Now, if you look closely, you'll see that there is an index here, like always. It begins at the integer 0 and continues on one at a time like this. So we can look at the index here for this particular data frame using the same index attribute. And you'll notice that it looks quite a bit different, the output. We don't have there's actually 4,916 rows. It doesn't all print them out. The default index, and this is true for all data frames, is going to be something called a range index. It'll begin at 0, go to the very last, and step by 1. You should notice that it is very similar to a regular Python object called the range object. So the range object and the range index are analogous. I'll set this one a little bit differently. There's always a start, stop, and step value like that. Same with the range index. So the reason Pandas has this, and this just, so what the range object does and what the range index object does, it just defines a sequence from start to end and by the step size. And it saves a little bit of memory. It doesn't actually put all of these integers in memory. It's only when accessed that it'll figure out what integer to return. So the reason Pandas uses this is to save a little bit of memory here, just so that it doesn't have to put all of these objects, all of these integers in memory. You can just define the sequence and then figure out what the index will be based on this sequence. So just a little bit of information on this default index, which is very simple, just a range of integers beginning at 0, going to n-1, and stepping by 1. In this video, we'll be setting an index on read. Let's go ahead and read in our movie dataset again and just look at the default range index. So if you don't want this index and you want to use a different column to be the index when you're reading in your data with the read CSV function, you can do so with the index underscore call parameter and setting it equal to the name of a particular column. So in this case, the title of the movie should be a good one to use, and that we'll just use that first column like that. So with this command, I'm going to rerun this, and now I have the title over here as the index, and each name of the movie now uniquely identifies the row. So that makes a lot of sense, actually. This is a movie or a data set about movies, and these titles are what we really care about, and they are the ones that will uniquely identify a particular row. So I want to discuss a little bit more about the index and how to use it. Let's go ahead and now select the index with the .index attribute, and we will assign it to some variable like that, idx. And although there are about 5,000 movies, it doesn't display all of them smartly. It just displays the first few and last few. So you can select a single value of an index with the square brackets, passing it in its position as an integer. So this is just like a list. This is no different than a list. So say I want to get the very first item in this index. Well, I can just put in 0, which is Avatar. I can get technically this is the 101st one, but with integer number 100, and so forth. like that. Now, slice notation also works with index objects. So I can go from, let's say, location 40 to 100, and I can get all of those movies. And then it also takes a step size, so I can move by 20 from 40 to 100 like that. So this is also the same as lists. What is unique about this square brackets that lists cannot have is that you can pass it in a number of distinct values. This won't work with a list. Let's say I wanted value 50, 70, and 3000, and that works. So it'll get each one of those and it'll return an index object of just those 3 values. So just a little bit more information about the index and then how to set it on read. In this video, I'll discuss how to choose a good index. So there are a couple qualities that I use when determining what to choose as an index. One is that the values are unique, and the other is that it is descriptive. So before I even choose an index, I should say that it is never necessary to choose an index for your data frame. You can do all of the data analysis that you want without ever setting an index. Now, there are some cases where having an index is helpful, particularly with time series analysis, but even then it is never completely necessary to use an index to complete whatever data analysis that you want. You can leave it as the range index. Okay, so let's read in this movie data set that we've been working with. And before we use this title column, that certainly seems like the most obvious column to choose as the index. And if you look through here, you probably will not find another column that makes sense. So definitely fits the descriptive part, but is it unique? There could certainly be movies that have the exact same title. So let's just do .head here so we can clear that up. So when you set the index, and this is possible with the set index method, we'll pass it in title. There is a parameter called verify integrity. Now, by default, this is false. If you set this equal to true, it will actually raise an exception if there is a duplication somewhere in this column. So it will not work. So this is a nice way to only set the index if, in fact, these are unique. And since this worked, we can certainly see that it did pass that test. So it is verified that it is in fact unique. Now, what is interesting is that in pandas, you can actually have an index where that is not unique. So you can actually use a column that has duplicates and it will work, well, as long as you don't use this. So let me show you that. Let's actually just move up here and say we want to set the index as, let's just say this color column. So obviously we can see repeated values already, and that's possible. You actually do not get an error over here. It's possible to use a non-unique column as the index. So that's just how pandas was designed. Now, if we go down here again and use color over here with verify integrity equal to true, then you should see that you will get an error and it says the index does have duplicate keys. All right, so that should help you on setting your indexes and choosing ones that are both unique and descriptive. In this video, we'll complete the exercises at the bottom of the Setting a Meaningful Index notebook. So exercise 1, read in the movie data set and set the index to be something other than movie title. Are there any other good columns to use as an index? We actually just saw that this isn't the case. There really aren't any other columns. Let's go ahead and read this in and do movie.head. So there really aren't any other good columns here. I don't think any of them are unique. So no, there really aren't any other good ones. So we're not even going to use one other than title. All right, so let's go down to exercise 2. Use set index to set the index and keep the column as part of the data. All right, so that is possible. Let's say movie2 equals movie.setIndex, and we'll we'll set the index as title, but if we press Shift Tab Tab, you can see this drop parameter is set to true. So by default, that means it'll drop it out of the columns. It'll no longer be a column. And if we set this equal to false, then it will not drop it. In fact, it'll keep it as a data frame column. So this isn't something common to do, but you can certainly do that if you would like. So now the title is both the index and a column. All right, moving on. Exercise 3, read the movie dataset and set the index as the title column. Assign the index to its own variable and output the last 10 rows. So we already have, movie 2, we'll just use this. It is set as the title column is set as the index. It says to get the index itself. So this is a case where I want you to actually get the index and then get the last 10 values. So we can use the square brackets and then slice notation. So we'll go from the -10 integer, that's 10th from the end, and slice all the way to the end. And that's how we can get the last 10 movie titles. All right, so it says exercise 4, use an integer instead of the column name for index call when reading in the data using read CSV. Since I'm lazy, let's go back up here and copy this. So the index call parameter, like I said originally, it can be a string, but it can also be an integer of the location of which column it is. So you can say, I want column number 5 or number 10 or whatever. We want the title column, which is column 0, it's the first position. And so you can use that as well, and the documentation strings go into that. All right, so that does it for the exercises. Welcome to notebook number 5, the 5-step process for data exploration. So this is a fairly simple and straightforward process that I came up with for my students to explore data within a Jupyter notebook. So when I was teaching, I noticed a lot of notebooks were becoming very messy. Students were becoming lost in their cells. They would lose variables. They would overwrite variables in the same cell. They wouldn't know what a particular variable was at one point. So I developed this to provide some structure when going through a data exploration so that you could keep track of what was happening and minimizing the risk of sort of losing a variable or just not understanding what exactly a variable was. So with that said, let's get to it, and let's go ahead and read the 5 steps, and then we will implement them. So step number 1, write and execute a single line of code to explore your data. So one of the main issues I had with a lot of students was that they wrote too many lines in a single cell. That's what I really want to avoid, especially when first learning pandas, when doing a data exploration for the first time. This is even what I do when I explore data. I try to minimize the amount of code that I have in a single cell. Okay, step 2, verify that this line of code works by inspecting the output. Number 3, assign the result to a variable. Number 4, within the same cell in a second line, output the head of the data frame or series. And number 5, continue to the next cell. Do not add more lines of code. Okay, so like I said, very simple and straightforward, but really will help you explore data in a Jupyter notebook. Let's go ahead and see this. We will read in the movie data set. And even here, we are sort of exemplifying this 5-step process. We're only doing one main line over here, and that is reading in the data frame and then just outputting the head and moving on to the next one. So let's just say we want to do some data exploration step, and we're going to keep it simple, and we're just going to move the title into the index. This is really the only thing that we've learned thus far. So we'll just say set index equal to title. So we'll write and execute a single line of code. That's all we're doing. And so that's it. That is step number 1. Step number 2 is to verify that this line of code works by inspecting the output. And this is key. When you're doing data exploration in pandas, you can't just assume that you've run the exact right piece of code and then try to do more data manipulation down here. We have to really inspect every single line of code that is written. And so if we look over here at the output, we see that it's returned the data frame, and it looks like it has put the index or the title in the index. So that looks correct. All right, so let's move on. And this is all going to happen in a single line. I should say this is all this 5-step process is going to happen in a single cell, but I can't show it in a single cell. We'll just show the final result in a single cell when we get there. Okay, so we've done step 2, we've verified. Step 3 is to assign the result to a variable. So we'll say, say something like movie 2, and so our single line of code is just this. All right, so movie 2. That is step number 3. We'll assign the result to a variable. So whatever data exploration step we did, we will assign it to a variable. Let's go ahead and execute that. Now step 4 is within the same cell in a second line, output the head of the data frame or series. All right, so again, we're not going to keep going and doing more, some more code, at least not yet. So I'm just going to copy and paste. So what we do here is once you've done your single line of data exploration or data manipulation or whatever you're doing in pandas, you will do movie.head, and then that sort of completes it. Step 5 is just go to the next cell. Do not add more lines of code. And the reason I like to keep things to a minimum is that you have very good traceability of your work. You can see that if every cell has one change to your data frame, then you can easily see where it's been and where it's come from. So you can very nicely step through your code one at a time. Okay, so that is it for the 5-step process. I highly suggest that you do this, especially when learning. When you get a little bit more advanced, of course, you can put more lines into a single line or single cell, and the final product eventually of a data analysis could be moved out of a notebook into a Python script. In that case, obviously, you'll have many, many lines of code, but the notebooks especially are very useful, and I think just easier to navigate if you keep the code in them to a minimum.
Congratulations on completing Intro to Pandas, the first course in the Master Data Analysis with Python series. You can continue learning with the second course, Selecting Subsets of Data, which is absolutely free. So in that course, you'll be learning how to select subsets from data frames with just the brackets, loc and iloc. You'll learn about Boolean selection, and you'll also learn about filtering with the query method. In that course is over 100 exercises with detailed solutions, and very importantly, there'll be a free challenging certification exam which will help validate the knowledge gained. This is an exam with over 50 questions itself, and will basically prove that you have mastered this material. So if this sounds interesting and you want to continue on your journey with the Master Data Analysis with Python series, then come join me and take Selecting Subsets of Data.